Welcome back to Advent of Code 2019. Day 20, the final week. Final week before Christmas. Alright. It's an even number, so that means it's a, last one was an int code. Okay, so this one's not an int code. As much as I like the concept of the int code, I really look forward to these ones which don't have int code. Alright. Donut maze. Hang on. Alright. You notice a strange pattern on the surface of Pluto. Wait, we're on Pluto now? Oh, yeah. Okay. And land nearby to get a closer look. Upon closer inspection, you realize you've come across one of the famous space warping mazes of the long-lost Pluto civilization. Okay. Because there isn't much space on Pluto, the civilization that used to live here thrived by inventing a method for folding space-time. I mean, that's basically why it's not a planet anymore, isn't it? It's basically a moon, or it's just a giant asteroid. Although the technology is no longer understood, mazes like this one provide a small glimpse into the daily life of an ancient Pluto citizen. This maze is shaped like a donut. Portals along the inner and outer edge of the donut can instantly teleport you from one side to the other. For example, this map of the maze shows solid walls and open passages. Every maze on Pluto has a start. The open tile next to AA. Wait, so A and A are... Huh? Are two separate tiles called A, but it's counted as a label. Okay. ZZ. Mazes on Pluto also have portals. This maze has 3 pairs of portals, B, C, D, E, and F, G. When on an open tile next to one of these labels, a single step can take you to the other tile with the same label. Let me just grab my coffee. Labels and empty space are not traversable. So you can only walk on dot. Okay, fine. Can take you to the other tile with the same label. But you can't walk on the... label itself. One path through the maze doesn't require any portals. Starting at AA... Starting where, though? There's 2 spaces for AA. Okay, starting at the bottom A, I suppose. Down 1. Right 8. Huh? Oh, I see. You only ever walk on the dots. but if it's adjacent to a set of letters, then the label is attached to that dot. So you're not going to have a situation where... I see. Okay. All right. You could walk from AA to the inner BC portal. Yeah. So you can teleport to this adjoining space. So the first thing we need to do, these labels aren't actually, they're just virtual. They're just labels. They're not actually part of the map. So once we basically assign status to these individual dots, you can discard the labels or just, I don't know, keep them in the map, I guess. They're basically empty space. So from this dot, it takes one step to go to this dot. So basically that's encompassed in our neighbor function. So this is just standard breadth first search to solve this one. This part one, at least. How many steps does it take to get from the open tile max AA to ZZ? Yep, sure. This looks easy, as long as we code it all correctly. And the labels are always outside the map. Interesting. So it's a linear time search. All right. Let's just code it then. Okay. So I think copy pos class. And then we want just, I don't know, do this. So just so taking each line, just putting it in. So grid equals empty list. Grid dot append. Let's do it as a mutable list because we might want to change some things inside the map. So we want list line dot strip. Okay. So we've got our grid. Then we want to look for all these labels. So we want to say... Go through the whole map. For every cell, if it's a dot and it's adjacent to a letter, then we need to identify the label. And then we want to make a hash map which maps for now, we'll map a label, the string, to a list of things which... Is there only ever 2? Let's have a look. Yeah, okay. It's only ever... They're all in pairs, so now we're thinking with portals. So let's say portals equals just a hash map. So for I in range... Alright, let's just get some... So nm equals length grid length grid 0. So I'm range n, j and range m. So we're going just cell by cell. If grid ij equals dot. So if we've got a dot, we want to see if we need a get neighbors function then. So let's say for a given position, we want a list of the 4 neighbors, at most 4. So for delta in, so it'll be like pause 1 0, pause -1 0, pause 0 1, pause 0 -1. Neighbor equals pause plus delta if it's within the bounds, so n and neighbor dot j, yeah, j m yield neighbor. Alright, so that gets the 4 neighbors, unless we're on the boundary or something. So we want to say if any of its neighbors, if, so we say grid neighbor dot I neighbor dot j, so that's the character, dot is alpha for neighbor in get neighbors pos ij. We just say pos equals pos ij. So use that variable. So that's saying if there is any letter next to us, that means this is a portal. Or actually better phrase it like this. For neighbor in get neighbors pos, if that is true, what do we want? We want the other letter behind it. So how do we do this? Okay, get the delta equals the vector that gets us from pos to neighbor. So neighbor minus pos. We might need a subtraction method. And then neighbor 2, so the second neighbor away, equals neighbor plus delta, right? Or we can just say this. So if we found one letter next to us, then doing this will get us the second letter away. Now, we don't know the right order, because we need to go left to right and up to down. So this is messy. Labels equals neighbor 2 labels dot sort. Hello, DJ. This problem we are doing a breadth first search through a maze, basically, just finding the shortest path from the start to the end, except you have portals, so you can teleport from a given portal to the same corresponding portal. It's a bit weird though, because they have labels which are in the map, but you got to pretend the labels are not there. But the labels are telling you that this space here is connected to whatever other space has HP next to it. It's a bit weird though, because the label could be on the right, it could be on the left, so you have to get it the right way around. That's what I'm trying to do now. But once you can extract all the labels then it becomes a straightforward map. So we want to sort according to left to right. So key equals lambda p map to p dot p dot j. Order them up. Yeah, do it like that. Then label will just be the two letters put together. So it'd be grid neighbor.i neighbor.j plus grid. Oh wait. We take the labels as the first labels and then do this again for the second. So it's ordered them So now we've got the label. And we want to say... Probably need to... Collections, import, default, dict. We want portals to be a default dict on a list. So we want to say portals for that label. Put in this pause. So we've attached that label to this pause. Okay, this is kind of horrific, but it's as complex as it needs to be, I think, given the fact that these labels are protruding from the map itself. So if this works, we should have a map of portals. Let's test this. Neighbor plus neighbor minus pos, because we don't have subtraction. List indices must be integers or slices, not pos. Ah, of course. I, j, I, j. So NL has these two positions. Alright, it seems plausible. Can I check one of these? ZF, well, that should be somewhere around 341. Let's see. Well, they're in order that they were added. Oh, balls. That's not right. .r. How did that happen? And then we have to break out of this for loop. Because if we found a label, that is the label. So we're done. Actually, we wouldn't need to do that, would we? No, we shouldn't need to do that. There's still something wrong here. Neighbor plus neighbor minus pause. Neighbor plus... So neighbor minus pause. I mean, no, it should be fine. So we're saying if there's a dot next to a letter, so a dot should only have one letter next to it at most. We're getting some correct ones. Then we get some wrong ones in here. E. Why did we get E and L? Something wrong with probably these three lines here somehow. So neighbor 2 should be one space away. So that seems correct. Now we sort it according to the I and the J. So labels is probably... We're getting the wrong labels probably. Let's see. Print was labels. So 30, 33. Let's try this. What? For I in range N, for J in range M. Why are we not getting earlier ones? We should be finding this one here. I equals 3. That's where we get ZF. Neighbor in get neighbors pause. If grid is alpha. Yeah, we're not getting nearly enough labels. What is going on here? Why is it only from... Oh no! Oh, I know what's wrong. I know what's wrong. Strip. The strip method is stripping out all this white space. But we want the white space this time. We just want to strip off the line break. I've made this mistake several times in past problems. Because sometimes he does inputs which have white space in them, and that's... I wish he wouldn't do that, because that kind of messes with our... Like, white space, it's normally assumed that white space can be discarded. It's not really a good practice to include white space as data. Because IDEs normally cut off the white space anyway. So what we need to do is, instead of strip, just replace line breaks with, just discard the line breaks. So line.replace n, then it wouldn't be a challenge to screw with preconceived notions, yeah. Well, the biggest problem is that some IDEs do it by default, and then you have to mess around with settings to stop removing white space. Because it's just so standard in programming to auto remove white space. If I were to edit this, this will probably happen right now. If I were to change a character here and then press save, or actually auto saves, so I wouldn't even have to press save, then I reckon it would actually remove this white space because that's auto formatting. So let's not edit it. But yeah, that can screw things up. And in general, that's what you want, because when people make code changes and then they publish their code changes and it creates a diff to see what it looked like before versus what it looked like now, you don't want to include all the white space changes, or you end up with this huge... When people are reviewing your code changes, they have to sift through all these white space changes to find the actual changes which matter. That's why IDEs normally just remove the white space, because it's considered to be not... Well, it's not code change. Isn't there a white space language? Yeah, there is. There is actually one. It's called white space. Yeah, the esoteric languages. Yes, you do not want to be using these IDEs. Well, you can, you just got to fiddle with the settings to not do that. Alright, so, because another thing is tabs. Normally, because it's an age-old war between programmers who want to use tabs and programmers who want to use 4 spaces. And no one's winning the war, so usually you just have an auto replace in the IDE to replace tabs with 4 spaces and so, or vice versa, whatever. So tabs becomes a problem if you're actually trying to put tabs into an input into your data. Anyway, I've just got to do replace that with nothing. All right, try that. I never understand the tabs versus 4 spaces thing. At my company, we normally preferred spaces, but the reason is because what was the reason? I mean, normally we would set up our IDE so that if you press the tab button on your keyboard, it would automatically insert 4 spaces. So that would appease both people. But when it comes to the actual code change, we would always want it to be spaces. There was some reasons why, I can't remember, but at the end of the day, you need one and not both. So that there's no, like, you don't end up with lots of white space changes in your code reviews. But as long as you can set up your IDE to do both, then it wouldn't. Seems spaces are always the same size. An individual space would be 1 character, yeah. Oh, what's going on now? Okay, we're gonna print the grid. We are getting empty spaces, but my worry is that... No, we are getting them on the right-hand side as well. Okay, that's as expected. Ooh. Why have we got a short line at the bottom? Damn it! See? This line. Now, did my IDE do that? Well, no, I think this is how the input actually came. See, there's no spaces at the end of this line here. So either we insert... I think this actually came in the input. Now, if I save... Well, don't press save, just don't do anything. No, it's auto-removing, see? So either I mess around with the IDE settings, but it shouldn't be doing that for... should it be doing that for text files? Is that what we would want? Not really. No, we want text files to be left exactly as they were. Let's have a look in settings then. White space. Oh, how about I add those spaces and then I add a new line. I think this is just a consequence of the way that text files are stored, I think. So we have to add a new line to preserve the spaces beforehand. So now if there's a new line, the problem is that will come through in our, I don't know. Yeah. No. No, it's still not working. Even that wouldn't do it. Oh God. Okay, what is the cleanest way to do this? I don't really want to change the input. We want it to work on the original input, so we just need to pad. See, my first thought was to replace all spaces with a new character altogether, like asterisks or something. That wouldn't actually work because there's no spaces here to replace. So I think we need to do... Oh. Yeah, okay, so... Alright, let's just take the first line, see how many spaces are in it, and say that's n, and from now on, just add spaces to every line until it's of size n. Oh, alright. Line, so... First equals true if first. Hang on, just do it like this. I hate using first variables. All right, so for k line in enumerate if k equals 0, n equals, wait. Now I wonder if the last line being cut off was an accident or not. I can check in the actual browser. In the browser, it's showing the spaces. So it's... Let me try copying it back in. And now... Don't touch anything, and now run. Wait, No, I need to just adjust this. So we need to say if it's the first line, then n is... Okay, so we do this. Oh. Okay, first just extract, knock off the new line character. Okay. N equals length of line. So now we've established the length of a line, and it's only doing that for the first row. And now from now on, grid.append. So it's going to be list of, so it's going to be L plus, and now we do an empty space times n minus length of L. So whatever, just add as many spaces as we need to make it up to n. And then m is just going to be Oh, no, 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 no. That was M, not N. And N will just be the number of rows. Right. That looks good. Okay. Take that out. Alright, we have a bunch of portals. Now, because we've got a list of portals, but it's not in the format we want, we have a mapping from a letter, pair of letters, to the two positions where its teleporters are. What we'd rather have is just this maps to that, and that maps to this. Discard the letters altogether. So, teleporter, I don't know, portal neighbor, because there's a unique neighbor. For P1, P2 in portals.values. So we don't care about the label anymore. Just take the pairs. Portal neighbor P1 equals P2. Portal neighbor P2 equals P1. So now we have a portal neighbor map. Apparently we have one portal with only one thing in it. ZZ. Oh, of course. AA and ZZ are not portals. Fine. Just to make things more confusing. So AA and ZZ don't have pairs. Okay, so if label is AA, start equals pos. So we found the start location. Elif. Yeah, entrance and exit. So elif label equals ZZ. Goal equals pos. Else. Put it in the portal list. Okay. Right there. So now we're mapping each one to its corresponding pair. Alright, that sounds plausible. Okay. Okay. Now we have the portals. So the true get neighbors method so this is like get the neighboring cells. But get neighbors. Okay, let's rename this one. Called get neighbor cells or something, because it's ignoring the fact that it's walkable. But get neighbors is now going to be purely about mapping walkable spaces to other walkable spaces. So rename. Get neighbor cells. Okay. Well, let's stop printing the grid as well. Alright, so get neighbor. Okay, so now we want the the actual get neighbors. For neighbor in get neighbor cells, if grid, so if that neighbor, if that location has a dot, yield it. And then we also want to go through the portal map, say if pos in portal neighbor yield portal neighbor pos. So we get one extra neighbor, an optional extra neighbor, which is the teleporter location. And that's also distance 1. It takes you 1 step to go through the teleporter. Okay. And now that all of that is basically to get this one method here, get neighbors. And now you just run BFS as normal, so let's define BFS for given start, given goal. Now we do the thing I've done a million times. We've actually had quite a few BFS problems this year, 2019. Alright, so I've started using is it called heap queue? No, what was it called? Port. Oh, I did it before. 19, 18, 19. Oh, DQ, of course, double-ended queue. All right, so Q equals Q. Can we just do this? Can we put start on the queue like that? Does that work? What are we trying to find? Just the distance. Okay, nice and simple. Don't need to output the path. Okay. Dist equals start 0 while q current equals pop left. So take off the queue. If it's the goal, if current equals goal, are we actually checking equality? We're not. So we do need to do that, otherwise it's not going to count them as equal, even though they have the same INJ. Define. Do we need to make it hashable? I don't know. I don't think we need this right now. Let's turn that off. Okay. Okay, for neighbor in get neighbors from current. If neighbor is already in the dist table, that means we already know how to get there, so we skip it. Otherwise, dist neighbor equals dist current plus 1. Pop it on the queue. It's all the same stuff. That should be it. print BFS start goal. Now, it's going to crash, of course. What's broken now? To pause object is not iterable, diffused. Okay, you can't do that. I thought you could just initialize it with so go do q.append start. Oh, what I was trying to do is like turn a sequence into a queue. So you could probably do this. Let's test this out. That's a sequence of one item. Will it turn that into a queue? I think it did. All right. None type object has no attribute I. So we're comparing it with none. Goal. We didn't get the goal. Did we not find ZZ? It should be that one there. Okay, let's see. No, okay, we have current equals goal. Huh? Just check print current goal. These shouldn't be none. None. Current is a none. So there's a none on the queue. So the only time we add stuff to the queue is here and here. Is this actually doing what we want it to do? Let's change it to this. No, so that was fine. So somehow we're getting a none here for neighbor. If neighbor is none, print that string there. Yeah, we are. Okay. For neighbor and get neighbor cells. If pause is none, print. No. If this is none, print pause. If for some reason we're getting a none here. No, we're not. Okay, so that's safe. Oh, yield. I wrote yield. That means yield none. It should be yield neighbor. Okay. 568. If we got to a number, I feel like it must be right, like, because otherwise it would label things with, like, invalid letters or can't really see anything going wrong. Alright, let's find out. Correct. Strangely, the exit isn't open when you reach it. Then you will remember, the ancient Plutonians were famous for building recursive spaces. Oh, there's the R word. The marked connections in the maze aren't portals. They physically connect to a larger or smaller copy of the maze. Specifically, the labeled tiles around the inside edge actually connect to a smaller copy of the same maze, and the smaller copies in a labeled tiles connect to a smaller copy, and so on. Ah, but they are numbered levels, so okay, I see. So the inner ones... So we start at level 1. Okay, so it's a bit like a dungeon with floors. It's like they're scaring us with this recursive spaces thing, but it's not that scary. It's just basically the inner ones go downstairs and the upper ones go upstairs, and each floor looks exactly like this, essentially. Alright. Brings you back to ZZ at the outermost level. Alright, I get it. So a location is now a pair with both, well... Okay, we can manually, the annoying thing would be to programmatically work out whether you're an inner or an outer here. We can kind of just do it manually, but it means it wouldn't work easily on the example inputs. Like, I could just say if it's greater than, say, this row here, and less than this row here, and to the left of this column here, and to the right of this column here, then that counts as inner. Okay. So all other outer label tiles are effectively walls. Okay. Any other level, A8 and ZZ count as walls. Okay, that's fine. So we start at level, let's say 0. So all the inner ones increase your level, and all the outer ones decrease your level. And if you decrease to -1, that doesn't count, so that's not a neighbor. Alright, we can handle that. Right, anyway, what is the goal? Just, okay. I don't think this is that hard. Some subtle changes needed, but it's... You just gotta think of it like a normal dungeon with floors. So we need to basically add this level. So, okay, let's say part 2. Reuse. Okay, so start and goal are the same. I mean, the map stays the same. The basically we want to override get neighbors method. So we can say, all right, DJ, see you next time. So I would maybe, okay, we want to change portal neighbor so that instead of all right. Let's make a method here. We decide if it's an outer or an inner. Define is outer. Is outer. Or is inner. Return. So we want the P. So we want P.I to be between. All right, let's just set some arbitrary locations manually. So let's say like here, it's be 19, 20. Okay, go with 20. So it's bigger than 20, less than 100, and is it a square? We can just say the same thing for. Not quite. All right, oops. Just J's. Okay, go with 17. Doesn't need to be perfect, but I just get it somewhere midway. Let's say 102. That if it's between those bounds, I would say it's an inner. Okay, so we want to say portal neighbor is going to map to a pair, so the location and the +1 or -1. So the inner will be +1. So it'll be, let's do that. That'll be 1 if is inner. Hang on. Yeah. P1 else -1. And here it will be similar, but it'll be 2. So that's saying if it's an inner, if P2, the one we're going from, is an inner, then we increase, otherwise decrease. And then get neighbor. Just take the first item there. So this should still work. 5, 6, 8. Okay. Now we want a new get neighbors method and a new BFS. Get neighbors 2 for a given pos and a given level. Yield neighbor, so same level for these ones. And for these ones, so it's going to be dest level delta equals, so just extract these two things, and we want to say yield the destination and level plus level delta. So that'll change the level. Okay. So now we get insert a pos level and we get out a pos level. Okay, and then the BFS. BFS2, from a given start to a given goal, it's going to be start level 0. And dest equals goal 0. I don't like this terminology. Hang on. Let's say start will be supplied as a level with a level as well. So it'll be start will be a position and a level, and so will the goal. All right, so don't do this. So we do this as normal. Just say, yeah, we put start in. Start is both of those things. Distance start to 0. Yep, that's fine. While Q current equals that. Current if current equals goal. Yep, that works. For neighbor in. So we're going to use get neighbors 2 current. You know, that's fine. Dist current queued up and neighbor. I don't need to change anything here. It's all depends on get neighbors too. The only thing we needed to change was get neighbors. So you could just supply get neighbors as a input to this. So the new start will be start 0, and your new goal will be goal 0. We want to ignore the negative ones, so if neighbor level is greater or equal to 0, that stops us from going into the negatives. Okay. Then will that just work? Get neighbors 2 needs... Okay, we supply pair. Unpack it. And then we'll repack it there. Print. Just that. Alright, let's hope it works. Now it's going through the recursive maze. 6546? I mean, I have no sense for what we should be expecting. But it works. Yeah, I mean, it's... You didn't have to change much. You just need to have the right get neighbors method. And it's just, don't worry about the scary recursive nature of this, because it's not really recursive. It's just defining a neighbor. This portal, it's not really a portal, it's just a staircase which leads to this point one level down. So you're just keeping your level, your location is now a pair, one being your x, y coordinates and the other item being the level. It's just, it's dwarf fortress, it's pathfinding in a Z level map. Straightforward, just don't get confused by the wording, really. That was just like a very textbooky BFS problem, I would say. I mean, it was a slightly original in its nature, but it's the kind of twist you would be expected to deal with when you do pathfinding algorithms, so yeah, pretty good. Pretty straightforward. Like, that's optimal. You could use a star of it. I mean, it took a few seconds, so you could use a star to... What would you do? Like the Manhattan metric in 3D? Yeah, you can do that. Number of levels plus the x distance plus the y distance. That would be the good heuristic. That might make it faster, but not by much. Probably would make it faster because this BFS is spreading out further and further with the levels, so you kind of need to home in a bit. So A star would be ideal if you wanted to optimize it a bit. Alright, nice easy problem. Sneak peek at what's to come. We're beyond Pluto now. Oh, it's an int code, of course. You lift off blah 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 blah. Something about logic. Oh, it looks like some sort of Boolean logic circuit. Hey. Looks like it might not be hard, but never know. Alright. Oh, that took me 1 hour 15. That's probably the fastest I've done any of the recent ones. As always, there is this leaderboard if anyone wants to do that. Yeah. Okay. See you possibly tomorrow for day 21. Bye bye.